Hello friends, are there any cases where functions are differentiable and it looks like L'Hopital is an appropriate way to solve it and still it doesn't work correctly? Yes, there are a few, but let me give you maybe one significant example where application of L'Hopital isn't that helpful. Let's see, if we have a limit x towards infinity, and let's say we have e to the power of x minus e to the power of minus x divided over e to the power of x plus e to the power of minus x. What do we have in the numerator? Well, we have plus infinity. What do we have in the denominator? Kind of the same situation. And both the numerator and the denominator are differentiable, so we can apply derivatives in both cases and see what's happening. So we're going to have a limit x towards infinity still, e to the power of x remains the way it is. It's going to be plus e to the power of minus x. And now in the denominator, we're going to have e to the power of x minus e to the power of minus x. Did it change anything? Well, actually not. And it won't change anything if we keep on going. So the denominator going to be flipping with the numerator and so on. So it goes on forever. What is the solution here? The solution here, do not use L'Hopital. That's it. That means we consider limit x towards infinity, e to the power of x minus e to the power of minus x divided over e to the power of x plus e to the power of minus x. Let us take e to the power of x out in the numerator and the same idea in the denominator. So what do we have? We have 1 minus, well, e divided over e to the power of 2x, right? And here we have e to the power of x, 1, well, plus the same. And you see, we can cancel those two. And this fraction is going to be running against 0, this one as well. So we're going to have 1 divided by 1, which is, of course, 1. So in case that we have a recurrent derivation of numerator and denominator where we see no significant changes, application of L'Hopital isn't that appropriate. So you should try to figure out the limits without using the rule of L'Hopital. Let us see maybe one more example. Limit x towards infinity. We got x minus sine of x divided over x plus sine of x. Okay, so once again, infinity divided by infinity. Both are differentiable, so let us compute the derivatives. We are having 1 minus cosine of x divided over 1 plus cosine of x. So what is the limit for cosine of x towards plus or minus infinity? Well, it's not quite clear. If we compute one more derivative, we're going to have a limit x towards infinity. 1 is gone. We have, well, let me stop here for a moment maybe. Is the further application of L'Hopital at all, like, is it a good idea? And the answer is, well, actually no. Because we just have 1 minus something, which is running between -1 and 1, and we have 1 plus something, which is the same. So we have kind of no further limit where we have infinity divided by infinity or 0 divided by 0, which are the significant cases for L'Hopital. So basically, I cannot go on further with this limit using L'Hopital. I can apply derivatives and I can see something maybe, but as you can see, it's maybe not the right result. On the other hand, if we ignore using L'Hopital's rule, which is, by the way, not the right case here, right? But if we are avoiding using the L'Hopital's rule, and instead of this, take x out, the same idea we previously used, it's going to be 1 minus sine of x divided by x in the numerator, and we have x 1 plus sine of x divided by x. So what's happening here? Well, we can cancel those two values, and if x is running towards infinity, this fraction is going to get to 0, and this one as well. So we're going to have 1 divided by 1, which is 1. And that makes sense. I mean, on the long run, x is running towards infinity. Taking sine away from it, at most, we're taking 1 away from infinity. It's nothing. And adding 1 here means nothing as well. So that's the story. What I wanted to say is be careful using L'Hopital. Make sure at every step, if you do it for many, in many steps, make sure at every step that this is still, well, like meaningful and makes sense without checking the conditions. You can get to some awkward places where no solution is possible by application of L'Hopital. Thanks for watching. It was my last video considering L'Hopital's cases so far, and I will go on with further solve problems in the next videos. See you guys.